Today we're going to look at one of the past paper questions from 2015 on features of graphs. Now, looking at this graph, the first thing they ask for is when f of x is not defined. What this means is there's no y value for any particular x value. And this often occurs when there are asymptotes, like when x equals 1. Or if there's a hollow circle but no filled in circle for a particular x value. So we can see at x equals 2, we have a hollow circle, but we do have a filled in circle. So it is defined for that value of x, and the same at -1. So there is only one point where it's not defined. The next thing it asks for is when it's not differentiable. Now, it's not differentiable when it's not continuous, which happens when there are hollow circles, like at x equals -1 and x equals 2. It's also not continuous at asymptotes, like when x equals 1. And again, if there are any jumps, but the only jump here as well is at x equals 2, so that's already defined. Now in part 3, they ask for when f"x is greater than 0. Whenever they give you something with f"x, they're talking about concavity. Now, if you think about your turning points, when f"x is greater than 0, it means it's positive. So it's like when it's a minimum, in which case on a minimum it's concave up. Now, the only area where this graph is concave up is between these 2 points. So here we'd give a range of values. -1 doesn't count, so -1 is less than x, which is less than 1. Note it's less than, not less than or equal to. Now in part 2, it's actually asking for the value of f of -1. When it's asking for a value, what it means is what is the y value when x is -1. Now if we look up from -1, the hollow circle is not the y value, that's just the limit. If you move on up, we can see the filled in circle is 3. So the value of f of -1 is the y value when x is -1, which is 3. And finally, it's asking for the limit of the function f of x as x tends to 2. To find limits, look at the function going from the left and look at the function going from the right. So as we head from the left, you can see that the function is heading towards 2. As we go from the right, you can see that the function is heading towards 3. Because they're not heading towards the same number, this means there is no limit. Other examples of limit we could look at is we could look at the limit as x tends to -1 of f of x. Now here, if we approach from the left, you can see it's heading towards 2, the y value of 2. If we approach from the right, it's also heading towards the y value of 2. So this means the limit as x tends to -1 is 2. It's the limit, not the actual value. So if they tend towards different numbers, then there is no limit. But if they tend towards the same number, then whatever that y value is the limit.